In this question, you could calculate all of the angles and then add them up. Um, and if there wasn't multiple choice, I think, to be honest, I would be very tempted to do that. However, if we look at the answers, we can see that they're quite nice, first of all, but they all depend on Q apart from this one here. So if we just work in terms of Q and forget about what the angles actually are, then we should be able to get the answer okay. The other reason for this is that this is a heptagon, so it's actually quite awkward to work out the angles. Q, for example, is the exterior angle of a heptagon, so it would be 360 divided by 7. And then the interior angles would be 180 minus that. So it's not looking good in that respect, but you can do that. I'm not going to go through it that way though, because it's actually much easier to do the following. So we've got P here, but because it's a regular heptagon, actually I could get rid of it and put it over here. And then because it's regular, I actually have an isosceles triangle here, which is exactly the same or congruent to this isosceles triangle here. So R and S are exactly the same, and I could even bring the S up here. So immediately I have that P plus S plus R is equal to 180. Now, T is also an exterior angle, so it's also equal to Q. And so overall, the sum is going to be this 180 plus Q plus T, which is also Q. So it's 180 plus 2Q. And that's the answer. So not too bad if you can realize that. Okay, there's other ways you can kind of do it. I think when I did it originally, I started um, writing I think I wrote that this was 180 minus Q, and this was P, and this is like I was doing this is 118 minus a half P, and somehow kind of working my way back to the same answer, but that is overly complicating it, so I don't want to go through that as like a model solution. This is the best way to do it.